let's go beyond the data here, and let's now dive into the different material types. I know that there is a wide variety of different materials, and based on the chosen material that's going to meet or withstand the environmental conditions, you also have different marking methods that are going to impact the ability to put an asset tag on an asset for the lifetime, the full lifetime of that asset. Take us through that.
This is probably the most important feature that I like to concentrate on, Peter, because when someone is looking to outsource IUID labels, the first thing that they realize is, hey, I know I got to get a compliant label that needs to last the lifetime of that asset. So as you mentioned, there are different material types. So the first thing you want to identify as best as you possibly can is try to understand what are the environmental conditions that these assets are going to be exposed to. And that will determine the proper material that will match up with those environmental conditions. Because one thing that I found, Peter, in the number of calls that I've dealt with is for customers who have a general understanding of the MIL-STD-130 compliance requirement, they get very concerned about, well, will this label be on there a year from now, 2 years from now? So sometimes there's a tendency to overcompensate and get a material that is more ruggedized or handles extreme durable conditions or extreme challenging environmental conditions such as extreme heat conditions, or it's exposed to acids or any type of material that could do harm to the label itself. Mm-hmm. So first and foremost, identify what the environmental conditions are that the labels and asset will be exposed to. Based on that, the company that you're dealing with should make a recommendation that meets those conditions. So for example, let's say you're marking some laptops. Well, generally they're going to be exposed into typical room temperature or office environment. You could easily get away with a basic polyester material with a marking method using a thermal transfer printer. By the same token, let's say you're marking some assets that are going to be exposed to outdoors and the sun is going to be beating down on that asset. Generally speaking, you don't want to use that type of marking method, because what's going to happen is the UV rays from the sun will eventually break down the mark or cause some fading. That label, keep in mind, it has to last for the lifetime of the asset. Not only stay on the asset and be visible, but it also has to be readable. The 2D data matrix barcode that's created based on the data that you've provided also has to be readable for the lifetime of that asset. So if you're using a marking method that's going to create some type of fading based on, let's say, the sun or the UV rays beating down on that asset, if there's going to be an audit check, let's say a year from now, and you've used that marking method, chances are if you go to scan it, you're not going to be able to read it. Now that label is not in compliance. Let's say you're in that type of environment. You want to use something a little more durable, a polyacrylic material. The Tessa brand is widely used for MIL-STD-130 compliance, and that marking method is using a laser etching process, which virtually eliminates any possibility of fading. It's the durability that you're looking for to withstand those types of conditions of UV rays. That's the material or marking method that you want to go with. To take it to the extreme, let's say you're marking a Humvee, or you're in a factory and you're using tool and die machinery, and you've got oils and other acidic chemicals that could be splashing onto the machine or to the label. Now you want to use an extremely durable material such as photoanodized aluminum, which virtually eliminates any possibility of damage to the label, because you have that photoanodized aluminum. It's imprinted into the anodonic layer of the metal. There's no chance of fading, and it can withstand all those types of harsh chemicals that could be exposed to the asset.
Well, you brought up a really interesting point and an important one there, which was about the readability of the barcode over the life of the asset and the fading or the damage that can take place to the barcode and deeming it unreadable. Verification provides that kind of quality and grade as to when the barcode is going to be readable from the moment it's created, which it needs to grade out at the proper levels through the life of that asset, and downstream, when someone else has it in their custody, has to grade out at a certain level. Speak to verification and the importance of verification to the process.
The verification called out in MIL-STD 130, when that 2D data matrix is created, Peter, based on the data given, it has to meet a certain quality grade. It can't just be willy-nilly created and you have your little barcode and call it a day. That grade level has to meet a certain standard of quality. So what happens is it goes through a verification process, and that barcode is read for the quality grade, and it has to meet that certain standard according to MIL-STD 130. You also have a validation process that's also done for checking of the syntax, confirming that you're using all compliant data within your cage code part number and serial number as well. So you have a two-check process, if you will. You have your validation check of your syntax, your data, and then the verification check of the quality of that barcode. Those two checks have to be met in order for that label to be considered MIL-STD 130 compliant.
I'm actually glad you brought that up too, because verification and validation, people get confused with that all the time and what that really means when it comes to this compliance obligation.
Absolutely, and just to reiterate again, the validation is you're checking the syntax, the actual data, and the verification is you're checking the quality of that 2D data matrix barcode that's created based on that data provided. And again, as I had mentioned earlier, you want to be sure you're using compliant data. Alphanumeric characters, dash or /. And again, if you have any non-compliant characters within your part number and serial number, you either need to remove those out or replace them with the valid characters such as a dash.